Okay, so to illustrate the use of the shell method, let's take this line, the linear function y is equal to -5 over 3x plus 5. The y-intercept is 5, the x-intercept is 3, as you can see easily here, right? If you revolve this about the y-axis, you will get a cone, the circular cone of height 5 and the radius 3. Now, you know the volume of such a cone is 1/3 times pi times r square times the height, which is, of course, 15 pi. You know this from geometry, and so it's nice to know the answer before you actually do a problem. And so let's check the shell method. For this, the volume is going to be 2 pi times what? The integral from 0 to 3. Remember, you go this way now because the shells are like this. These are the shells we're thinking about for each x. Now remember, this is 2 pi x times the f of x, right? F of x in this case is -5 over 3x plus 5. Don't forget this x in front of the f. In the disk method, you have f squared inside of the integral sign. For the shell method, you have x times fx, and then 2 pi in front. So this is what you would have to integrate. Let's go ahead and to multiply everything by x inside. You have -5 over 3x squared plus 5x, which is what you would integrate. And so this is 2 pi, and this will be -5x cubed. Is that right? Yeah, if you have -5x cubed, when you differentiate, no, that's not true. It's 5 over 9, right? See, that's why you integrate by as soon as you think you got the integral right, you differentiate this. I almost fell for it, right? So if you differentiate this mentally, you have -5 over 9 times 3, so -5/3 x to the square power. Right, and this is 5 over 2x squared. Yeah, all right, and then this goes from 0 to 3. Make sure you have the parentheses. Okay, so now plug in 3. 3 times 3 times 3 is 27. So that part is 5 times 3. And then 5 over 2, and then plug in 2 to the third, which is 8. Okay, so this inside is going to be simplified. -15 plus, and then that's 20. And that turns out to be so it does not turn out to be right because I entered this incorrectly. Not 2 to the third. I have 3 squared, which is 9. Okay, so that's 45 divided by 2. And so, yeah, you can just multiply this out like that, 2 inside. So it's negative. Okay, so it's -30 and then 45, right? Positive 45. So this is 15 pi, as we knew the answer should be. Okay, so that's one way to apply the shell method. By the way, if you decide to do this using the disk method, what would you have to do? If you decide to do this using the disk method, right, because you're rotating this object about the y-axis, you would have to use the integral with respect to y. Okay, so if you are using the disk method for this, okay, then you would have to say the volume is pi times the integral, and you have to go this way. So it goes from 0 to 5 of what? Something square, right? And what you have to square is not this function, but remember, you have to solve this for g, okay? Sorry, you have to write x in terms of y. So you have to write a new function, which is g of y, which expresses, you have to solve this for x. And x is equal to g of y, and that's a function you square, and you integrate that squared function as y goes from 0 to 5, and then you multiply that by pi. And you will get the same answer, okay? But that's what you would have to do. You have to do a little prep work in switching that function to obtain the expression for x in terms of y. Okay, now just generalizing this is very similar. What I'm about to do is very similar to this. In fact, this is just a generalization of this. But verify that the volume of this circular cone is 1/3 pi r square h. Okay, we did something like this before using the disk method to actually prove that. But how can you do that using the shell method? Well, if you want to do this, then you have to clearly have a function where this is h and this is r. So the function that you have to define is, what's that? The slope has to be negative h over r. And then the y-intercept has to be h, right? So this is what you have to integrate. This is the function you have to revolve about the y-axis to obtain this circular cone, right? And x goes from 0 to r, of course, right? So the volume is, using the shell method, it's 2 pi times the integral from 0 to r of this. Oops, it's actually it's x times this. So go ahead and write x first. And then this is with respect to x. So this is 2 pi. And then you have negative h over r x squared plus hx. That's what you have to integrate. And this is the integral. Actually, let's just integrate at this point. Negative h over r x cubed. But now you want to put 3 in front, right? And then you have h over 2 and x squared. You integrate this from 0 to r. And by the way, as soon as you integrate, make sure you remove that integration symbol. This integral symbol should not be here once you integrate it. Okay, so it's 2 pi, and then you have negative h divided by 3r, but then you have r cubed. Okay, we will get rid of certain things here. And then this is r squared. And of course, minus 0, right? When you plug in 0 here, you just get 0, so you don't have to worry about that part. And I see that I have r here, and r squared is what's left here. So 2 pi times negative h over 3 r squared plus h over 2 r squared. And when you do this, okay, so it's basically 1/2 minus 1/3, okay, which is 1/6 of h r squared is what you get. And of course, this is 1/3 pi r squared h, as you expect. So that is another verification that the volume formula is correct for circular cones. Okay, so you can practice your exercises and again, learn to carry out the shell method.